Given a string, split it into as many parts as possible so each letter appears in at most one part. Return the sizes of those parts. In the example, the first part must stretch through the last A, and by then B and C are also contained, so we cut length 9. The next closed range has length 7. The final closed range has length 8. So the output is 9, 7, 8. Second example, every letter's last occurrence stays inside the whole string only when we take all 10 characters. So there is one partition, with size 10. Before building a map, ask why boundaries matter. If a partition starts with this first A, we cannot cut before the later A at index 8. Otherwise the same letter would appear in two parts. So including a character forces us to include its final occurrence. First, pre-compute finish lines. On this shorter input, A ends at index 8, B at 5, and C at 7. Later, D ends at 14, E at 15, F at 11, and G at 13. Now scan from left to right, using the finish lines we just computed. For each character, look up its last index, then update end. Index 0 is A. From the finish line map, last of A is 8. So end becomes max of 0 and 8, which is 8. Index 1 is B. Last of B is 5. Since 5 is inside the current boundary, end stays 8. Index 2 is A again. Last of A is still 8, so the boundary does not move. Index 3 is B again. Last of B is still 5, so end remains 8. When I catches end, every letter inside this segment has finished. So the first partition is sealed, with length 9. Move start to the next index and reuse the same rule. The remaining letters build a fresh boundary ending at index 15. The idea is simple, pre-compute finish lines, then walk until the boundary catches up. For this input, the partition sizes are 9 and 7. The algorithm is just 2 passes over the string. Pass 1. Scan once and record the last index of every letter. Pass 2. Walk again. Stretch end to the latest finish line, and cut whenever the index meets end. Now I meets end at index 8, so we cut the first partition. Its length is 9. Again, I meets end at index 15. Cut the second partition, length 7. Finally, I meets end at index 23. Cut the last partition, length 8. 3 partitions of length 9, 7, and 8. Time is O of n, because we scan the string twice and each scan is linear. Space is O of 1 because the string only has lowercase English letters, so the last index map has at most 26 entries. As usual, the returned answer list is not counted as auxiliary space. Define partition labels on the input string. Create a map for the last index of each letter. First pass, visit every index in the string. Store this index as the latest position for the current letter. Set start to the beginning of the current partition. Set end to the current partition boundary. Create an empty list for partition sizes. Second pass, visit every index again. Stretch end to the farthest last index seen so far. If the scan index has reached the boundary, we can cut. Add the length of this partition to the answer. Move start to the next position. Return the partition sizes.